Welcome to the second part of the video, and in this video we are going to solve 6 more problems from the chapter Errors and Measurements, and the problems are from previous year's NEET exams. So our first problem is time intervals measured by a clock give the following readings: 1.25 second, 1.24 second, 1.27 seconds, 1.21 seconds and 1.28 seconds. What is the percentage relative error of the observations? And 4 options are given. So to solve this problem, we will first calculate the mean time interval, which is given by sum over time intervals by total count, which is equals to 1.25 seconds. Now from this value, we can calculate mean absolute error, which is equals to mod of delta t1 plus mod of delta t2 plus mod of delta t3 plus mod of delta t4 plus mod of delta t5 over 5. Now here delta t1 is given by mean time interval minus the observed time interval. Therefore, delta t1 is 1.25 minus 1.25, whereas mod of delta t2 is equals to 1.25 minus 1.24. So here 1.25 is the mean time interval and other values are the observed time intervals. And for the rest of the quantities delta t3, delta t4 and delta t5, you can write the similar things. And this gives 0.02 seconds. That is, mean absolute error is 0.02 seconds. Now from this data, we can calculate percentage relative error, which is equals to delta t bar by t times 100. And if you put the values of delta t and t, then you will get percentage relative error is 1.6%. Therefore, option D is the correct answer. Now let's go to our next problem. Our next problem is taking into account of significant figures, what is the value of 9.99 meter minus 0.0099 meter? And 4 options are given. So if you subtract 0.0099 from 9.99, then the result will be 9.9801. Now, as per the rule of least number of place in decimal portion of any number, the result should be equal to the number of decimal places of the term in the operation containing lesser number of decimal places. So the correct answer should be option D, which is 9.98 meter. Now let's go to our next problem. Our next problem is, in an experiment, the percentage of error occurred in the measurement of physical quantities A, B, C and D are 1%, 2%, 3% and 4% respectively. Then the maximum percentage of error in the measurement X, where X is given by A square times B to the power half over C to the power 1/3 D cube will be, and 4 options are given. So it is given that X is equals to this quantity. Now, as explained before, probably in the previous video, that the percentage of error in X can be calculated from the above expression in 2 steps. In the first step, you have to take the logarithms on both sides of the expression, and then in the second step, you have to take derivatives on both sides multiplied by 100, and after that the percentage of error in X will be delta X over X times 100 equals to 2 times delta A over A times 100 plus half times delta B by B times 100 plus 1/3 delta C by C times 100 plus 3 times delta D by D times 100. Now in the question, percentage of error occurred in measurements of these physical quantities, that is A, B, C and D are given, which are 1%, 2%, 3% and 4% respectively. So if you put these values, then you can calculate the percentage of error in measurement of X, and this is equals to 16%. Therefore the correct answer is option B. Our next problem is, the main scale of a vernier caliper has n divisions per centimeter. N divisions of the vernier scale coincide with n-1 divisions of the main scale. The least count of the vernier calipers is, and 4 options are given. Now according to the question, nth division of vernier scale coincides with n-1 divisions of main scale. Then we can write n vernier scale division equals to n-1 main scale division. Therefore, 1 vernier scale division is equals to n-1 over n main scale division. Therefore, least count is given by 1 main scale division minus 1 vernier scale division, which is equals to 1 main scale division minus n-1 over n main scale division, which is equals to 1 over n main scale division. Again, 1 main scale division is equals to 1 over n centimeter. Therefore, we can write 1 over n times 1 over n centimeter, which is equals to 1 over n square centimeter. Therefore, option C is the correct answer. Our next problem is, a student measured the diameter of a small steel ball using a screw gauge of least count 0.001 centimeter. The main scale reading is 5 mm and 0 of circular scale division coincides with 25 divisions above the reference level. If screw gauge has a zero error of minus 0.004 cm, the correct diameter of the ball is, and 4 options are given. We know that reading of screw gauge is given by main scale reading plus circular scale reading times least count plus 0 error. So if we put all the values, that is main scale reading, circular scale reading, least count and 0 error, then we will get the final answer 0.529 centimeter. So correct answer is option D. Now let's go to our last problem, which is, in an experiment 4 quantities A, B, C and D are measured with percentage error 1%, 2%, 3% and 4% respectively. Quantity P is calculated as follows. P is equals to AQ BQ by CD. Percentage error in P is, we have to choose the correct answer from these 4 given options. So let's solve this problem. According to the question, it is given that P is equals to AQ B square over CD. Now to calculate maximum percentage error in P from the above expression, first you have to take the logarithms on both sides of the relation given, and then you have to take derivatives multiplied by 100, and then you will get the expression for the percentage error in P, which is given by 3 times delta A over A plus 2 times delta B over B plus delta C over C plus delta D over D times 100. Here we are calculating maximum percentage error, that's why we take only positive signs. Now this can be written as follows. And if you put all the values, that is the errors in measuring A, B, C and D, then you will get the final answer 14%. So the correct answer is option A. So that's it for now. In the next video, we will solve problems from the chapter Vector Algebra.